In this video, we're going to just look at basic materials construction and how you can set up materials to apply your own colors and effects to objects and shapes in your world. I've just used the Place Actors window to place a series of spheres here into my level. And in my content browser, I've created a new folder for my materials. In here, I can right-click and select material to create a new material. I'm going to name this one M for material base mat. This is going to be the base material that we use for a number of other materials later in the video. And if I open that, we are met with the materials editor. Make sure that you move this window or place it somewhere that you want to use. I tend to dock all of my windows next to my level up here so that I can flick between them at will. But the materials editor looks a lot like the blueprint graphs that we've used earlier. It moves from left to right with all of the inputs and calculations going on the graph ending up plugged into this final node here, which will share the same node as the material itself. There are a lot of options here, but to start with, let's just create a basic material which will allow us to control the color, roughness, and metallic values of the objects we place in our world. When you are placing nodes into the materials editor here, the most common ones that you are going to find yourself using are single numbers to add a value into, say, the metallic value, roughness values, or if you wanted a flat base color, you could plug in a single color value from 0 to 1. That would give you grayscale, or vectors, three values. This gives you your RGB colors, and the multiplication nodes, and the panel. We're going to talk about all of these as we go on. So how did I get those to appear in front of me? You can either go into the palette on the right hand side here, and you can find all of the different constants which are used to add values to this graph. So for example, if I click here where it says constant 3 vector, drag one of those into the graph, this gets me a constant 3 vector, which is an RGB vector. Those are the three constants, R, G, and B. So if I set this to, say, a bright purple, and plug in the white node combines the R, G, and B nodes, or you can break them off individually if you want to access those individual values. When I plug that into the base color of the material here, our preview scene changes color to match the color that we've just plugged in. Next to these values here in the palette, you see the keyboard shortcuts 1, 2, 3, and 4. If you want to get a constant 1, just a single number to work with, you can, for example, go into the palette, find a constant and drag it in, or, because the keyboard shortcut is 1, you can just hold down 1 on the keyboard and click, and it will create a constant node, or, like the other blueprint graphs, you can right-click and you can search for what you want instead. In this case, here we go, constant. These are all exactly the same node. There's just 3 different ways of getting at them. The fastest way is to use that keyboard shortcut. If you need a single number variable to start playing around with the values, hold down 1. In this case, this constant I'm going to plug into the metallic value, and nothing will change because this value is set to 0. We are telling this material that it is 0 metallic. It is to have 0 metallic effect. If I start to change this, you'll see the preview starts to change as well. So at 0.5 metallic value, we start to see a bit more of a shine. Some of the reflections are a little bit more obvious, and the closer we get to 1, the better that reflection is, all the way up to 1, where we get a surface here that now looks quite a lot like a powdered metal. It has this odd luster to it that reminds you of metal, but it's not completely metallic yet. There's something off about it, and this is because we're not controlling the roughness value. So I'm going to create another constant, and I'm going to plug that into the roughness value, and immediately we now see a much more mirror-like metallic finish. That's because we are telling this material that it is to have a value of 0 for its roughness. It is replicating a completely, perfectly smooth surface. If I start to increase this roughness value, that reflectiveness will sort of haze away as we increase the roughness of this surface material until I get all the way up to something like fully rough, which will look extremely odd indeed. Light barely bounces off this at all. It casts almost no reflections. It's a very odd material. Be careful cranking your roughness up this high. It can start to create some very odd effects. But if I wanted something to look like a, say, glossy painted plastic, I could include a very, very low roughness value, so it's smooth, and turn down that metallic value to something like 0.1 or 0 to create this extremely soft glossy object with some high reflections in it, but it doesn't look metallic. This is perfect for a shiny plastic. Or again, full metallic values and a very, very low roughness. And this is how you can create extremely effective metals, like this gold value. So I'm going to leave that where it is for now. You can start experimenting with all of these different numbers and colours to create whatever effects you want. But to use these in your level, we're going to be following the same sort of process that we did for our platform. We could go into this level here and try and apply our material directly to these objects in the world, but it's not going to work straight away. As you can see, this doesn't look like gold at all. It doesn't look the same as it does in the editor here. When you're working in materials, you must apply your changes by clicking this apply button up here in the top left, or you can click save. It'll do much the same thing before you try applying them in the world. Now you can see my material in my browser is being correctly previewed, and I can drag and drop this onto the objects in the world and see how they start to look with the light on them. But this is not a particularly efficient workflow. If I wanted different colours, I would have to create a completely separate material and set it up like I did every single time for each colour and each version that I want to put in the world. Instead of doing that, we can parameterize these values so that we can change them and create material instances to use inside the editor. To do so, select one of these constants, right-click on it, and change it to a parameter by selecting the top option, Convert to Parameter. It will ask you to name it, so this is going to be Color. And I'm going to repeat the exact same process here for the metallic value. Right-click, Convert to Parameter, Metal, and the roughness value, right-click, Convert to Parameter, Roughness. Now save that and apply it. Nothing will have changed immediately. There still doesn't appear to be any way to change these settings live. But with the base material in your content browser, right-click on it and create a material instance. Material instances use the exact same code compiled from the base material, so the shader code doesn't change. They're extremely fast and extremely easy for your graphics card to render. However, they allow us to change some values. If you double-click on it to open up the material instance, you'll see it's a very different window to the material editor that we were working in before. I don't have a graph, I can't make changes to the way this material is put together. But here on the right hand side I can see the scalar parameters that we just created inside of the editor. So color, if I check this box, I will be able to start editing the color for this instance of the material. So if I set this to a pale blue, and then I can change the metallic and roughness values as well. So let's make this one non-metallic, but very smooth and shiny. And if I apply this material instance to an object in our world, I don't need to recompile it, I don't need to wait. These simple changes to these numbers will affect this material instance directly in the world. And what you can do with material instances that you can't do with regular materials as well is to preview the changes in real time. If I look at these two spheres here in my level, and I change the color for my material instance, I can see how it would look with different colors live in the lighting for my level. Whereas if I wanted to change the color for this gold material, I would have to go into the material editor, change the color of the gold to say red, press OK, save, compile, go back to the level, and then I would be able to see the changes. So the material instance system is a much faster way of previewing these changes. So I'm just going to rename this pink material that we created m_gloss pink inst. It is an instance, not its own material. And I'm going to create a new material instance. This one m_gold inst. And I know that to make a gold, I can just change this to a soft yellow. I'm going to keep the metallic and roughness values the same. Apply that to a different object here. And I'm just going to create two new material instances for these last two. This is going to be a mid m_blue inst. And that's just a flat blue that you could be using to replicate any surface you wanted. And a final material. Brown inst. Let's create a brown color. And I'm going to reduce that metallic value right down and keep the roughness value pretty low too. So in this way, when your project is compiled, you'll have to spend very little time preparing shaders, because although there are 5 different objects on the screen in front of us using 5 different colors and reflectiveness, roughness settings and metallic values, they are all being viewed using the same shader, the same base material. So if you can work like this, coloring things in your world and level using material instances instead of base materials for each object, you will have a project that loads very quickly and runs very efficiently on your users' computers.